Welcome to Masters of Regeneration Radio. Conversations with humans who dare to reimagine our place on planet Earth. Earth is changing fast. Evolution happening in real time. An intimate, circular understanding of nature and living systems. We are the land. The land is us.
You can hardly go by a day without using a plastic product. The problem is that only a small percentage is really recycled and reused. This exponential growth and accumulation is very bad for the environment, especially the waste in the oceans. We'll have more plastic waste than fish by 2050. So once the waste gets into oceans, it's irreversible because the cost of cleaning the ocean is enormous. It's called hydrothermal liquefaction. The polymers will sort of melt in the high temperature and dissolve in the supercritical water. And then in this state, they can convert into oil or monomers or gas. It's a very versatile, powerful technique. If we can convert this into valuable, useful products, that will create a driving force to reduce the plastic waste accumulation and also reduce associated risk to the environment.
Hey everyone, welcome to episode 19 of Masters of Regeneration Radio. I hope you enjoyed part 1 of this 2-episode special on plastic. In the first episode with Tony Rossi at Loop, we talked plastic recycling in the coalition of the biggest brands in the world to redesign containers to start replacing plastic by other materials and the massive issue of actually recovering plastic from, well, everywhere on the planet, from landfills to the oceans and everything in between. We are at a turning point in human history. The vocabulary we use to define the challenges of our time must change now, and by the millions. We must stop blaming stuff around us. Instead of saying we have to fight climate change and global warming, we need to turn our attention to how we humans manage the land. This is not about beans or beef. It's about toxic feedlots and toxic agriculture and gold mines, poisoning rivers like the Amazon. The red tide in Florida, the sargassum crisis in the Caribbean, thousands of fish, manatees, insects, and people are also dying because of human toxic management of the natural world. We have disrupted the biogeochemical cycles of nitrogen and phosphorus. There's an excess amount of those nutrients in the oceans. That's why the seaweeds are going crazy around the world. That's what we need to fight right now. It's our own blindness, and we must do this now. If there was one goal for humanity, one overarching goal that we must all embrace, it's to protect the natural world, to protect life, the health of living systems. This is what must drive us. Please raise your ambition today. I want to invite you to raise your ambition to become a hero for life on Earth, a protector of the natural world, with your conscious choices, with what you decide to give your money to. You've worked hard to earn it. Don't give it away to companies polluting the environment. I don't know about you, but this is definitely personal. If I can't trust what I eat, what I drink, what I breathe, what I see, and what I hear, there's noise pollution. I can't see the stars at night. I can't trust the water I'm drinking in big cities. I don't know. I love everything that's good about life, including food, including good water, including a breath of fresh air. On top of that, our oceans are flooded with billions of tons of plastic. And if we don't have healthy oceans, we have no air to breathe. It's as simple as that. Did you know plankton produces half the oxygen we breathe and captures 1/3 of the excess carbon in the atmosphere? Again, we got to be obsessed with plastic pollution, with climate change, and obsessed with how we manage the natural world, how we use the resources of the planet. And we must be obsessed with redesigning our Homo sapiens management of those resources to circular, regenerative models where the number one overarching goal is always to protect the natural world. On today's episode, our guest is Linda Wang. Linda is the Maxine Spencer Nichols Professor in the Davidson School of Chemical Engineering at Purdue University. In 2011, a major producer of plastics asked her team to develop a method to recover polycarbonate from electronic waste. They developed the first extraction method to recover high purity polycarbonate, and they also developed a new separation method to recover flame retardants from the waste. All right. During this research project, however, she realized that the polycarbonate waste is only 1% of the total plastic waste. And the total amount of plastic waste has been growing exponentially over the past 6 decades. You can only recycle plastic so many times. So what do you do next then? Linda and her team have come up with a solution using supercritical water to create fuel out of plastic waste. This episode 2 of our plastic series is yet another example to show all of us that it is possible to change reality and tackle very objective problems. We just need to imagine. We just need to give ourselves the permission to step up and imagine a different role for ourselves as managers of the natural world, to roll up our sleeves and get to work. There's so much work to do. Before we jump right in, and if you're enjoying our content, I would be so grateful if you went to iTunes or Apple Podcasts on your iPhone and gave us 5 stars and a great review. These help us grow and get this information to more people like you who are ready to support this global transformation and share important knowledge and inspiration. All these stories of the heroes of our time. This is episode 19, humans, of Masters of Regeneration Radio.
Yes, that's the worst thing. You throw the plastic waste into the river or into the oceans. Plastic actually is a shortened name from thermoplastic.
Okay.
And this describes the polymers that can be shaped and reshaped using heat. So it has many wonderful properties, right? It is lightweight and strong. It can be shaped into different shapes very easily.
Yeah.
It's low cost. It's convenient, and we get addicted to the use of plastics. But unfortunately, most people don't know the fate of the plastic waste.
Yeah.
Where did they go? They think they put it into the recycle bin. That's the end of the story. That's not. Yeah, that's very sad. That's why I want to take every opportunity to inform the public about this danger of throwing plastic waste into the trash can. Landfill, that's probably has a less risk, but as you know, most of the landfills are not perfect, so they still continue to pollute the groundwater and soil.
Yeah.
And the worst thing is that they degrade slowly into microplastics and many other additives and chemicals. And this, once they got into the rivers and into the oceans, the consequence is irreversible, basically, because
do you know how much water in the oceans in the planet? It's a huge amount.
Yeah.
So, so the cost of cleaning up the ocean water is unimaginable. So, for example, if you think about 0.3 cents per gallon of water treatment costs, but still the amount of water in the oceans is 10 with 20 zeros after that many gallons.
Yeah.
So if you multiply these two quantities together, you come up with 10 to the dollars with 18 zeros, okay, the dollar amount. God. So that is 10,000 times the global GDP. So that means, in my opinion, with the best current technology, the water pollution, the pollution of the oceans is irreversible. And because I have been doing research for separations for the last 40 years, and I know the cost of processing and separations. And that when I first came up with this number, I was very depressed because most of people don't know the danger of throwing, nuclear waste or plastic waste or all these bad things into the oceans. And so I thought this is probably a more serious threat than climate change.
Yeah.
Because the because the microplastics and this chemicals in the plastics, they cannot be retrieved completely. So so that motivated me to try to find a solution of this problem. So that's how we started a few years ago. Because we have very limited funding, so we decided to focus on the majority of the plastic waste, which is type 2, type 4, and type 5. And these are the high-density polyethylenes and low-density polyethylenes. Type 4 and type 5 is the polypropylene. So let me explain type 2.
I was just going to ask you, yes, if we could go into the details of all those technical, different.
Right.
Yes.
Type 2, for example, your milk jugs.
Okay.
And your shampoo bottles. Okay. Your grocery bags.
Okay.
You go to the grocery store. I don't know whether they banned this grocery bags in California or not, but type 2 is the plastics are used mostly in the containers, food containers, and the grocery bags. And type 1 is most well known, which is your water bottles. The single-use water bottles. That's type 1. Type 3 is the PVC pipes. If you look underneath your sink, the white pipes probably are made of PVC. Type 3. Type 4 is the shrink wraps, Ziploc. Bags. This is low-density polyethylene. And type 5 is polypropylene. These are your pill bottles, supplement bottles, the disposable tableware, the forks and knives, and the straws. I don't know whether you have banned the straws in California, but that's type 5. Okay. And type 6 is polystyrene, which is when you have leftovers in the restaurant, you take home with these clamshells. These are polystyrene.
Like the styrofoam?
Right. There's the styrofoam, yes, boxes. Type 7 is everything else, like I mentioned polycarbonate, this computer housing, your compact disc. That's polycarbonate, and so all the other fibers, polyester fibers in clothing, that's type 7. So type 7 is everything else, many other smaller amounts, but still, very prevalent in your daily lives.
So all of these all of these are polymers.
Right. they're easily shaped by using heat. That's why it's called thermoplastics or plastics.
I see. And what are those polymers made of?
They're made of a wide variety of chemicals. Polyethylene is from natural gas. The small molecules, you link them together into a polymer. So the compositions are widely different from type to type. So, but
I see.
so they're roughly classified into 7 types. Type 1, 2, 3, 4, 5, 6, they have defined chemical structures from the raw materials, but type 7 can be, complex mixtures, composites, various cats and dogs, different types. So that's, they're roughly classified into 7 types, but the seventh type is really a complex things of various polymers.
Because it's too diversified, or is too complex mix?
Too many, it's just varies made from various chemicals. So the polymers is just you link a monomer many times into a long chain, and that's called a polymer. And when you link different chemicals, you can get different polymers.
I see.
Yeah.
So what excites me about your work, and why I'm interested in talking about your work, is the fact that you have thought about, the whole circular, say, trajectory of these components, right? Like how do we transform them and put them back into, is it the ground, is it the atmosphere, or into a use that makes them sort of lose that form, that hardened and hard to decompose form, which is plastic?
The technologies are very advanced to make them into this polymers, and they are made into different products. And but they usually have colors, different dyes, additives, plasticizers, and various additives as they fall apart, as the polymers fall apart into fragments. They first, degrade into microplastics. I think you probably are aware of microplastics everywhere, right?
Yeah, I think everybody is by now aware that there's some sort of plastic in the ocean, in the fish.
Right, in the fish, in the shrimps, in the planktons, they ingest this microplastics because they confuse them with foods, because they look like food and smell like food. So eventually this is destroying their ecosystems. You probably have seen the coral reefs with plastic bottles stuck in and the various turtles eating plastic bags because they confuse the plastic bags with jellyfish. So there's some biologists studying why the sea animals like plastics. They like to eat plastics, but this can cause very bad damages to them too. So I don't know whether you have seen the before and after pictures of the Henderson Island in the South Pacific Oceans. In 1992, when they filmed the Mutiny on the Bounty, or it's called the Bounty, the beach was still pristine, but in 2015, that beach was full of plastic waste. It's really a very sad contrast, because it's only 23 years difference.
Oh my God.
The change is very dramatic, and but that's only the surface. What is underneath the oceans? They found this microplastics in the organisms and creatures deep in the deep sea also.
Oh my God.
I don't know whether you see the plastic bag 8,000 feet down underneath the Arctic Ocean, which was, the biologists were trying to find some exotic organisms. They found plastic bags. It's really sad. It's
Oh my God,
everywhere.
it's
I mean,
so appalling. Yes.
Yes, if you have to clean up oceans with 8,000 feet depth, you can imagine the cost. Just going down there is very costly. Not to mention to clean it up. So I realized in the around 2015 that this is a pending disaster in my view, because we just cannot afford to clean the ocean water because the huge volume of it. And the worst is that the public is not aware of this threat. Their emphasis a lot is on the climate change. I think you probably heard about the Stephen Hawking. He mentioned that humankind probably have to find a new planet in 100 years.
Yes.
But he mentioned climate change was one of the reasons, and nuclear warfares and these kind of things were in his calculation. That was, I think it was May 2017, he made that remark. But I was almost calling him to tell him that 100 years may be too optimistic of projection, because by 2050 you have heard the comment that, well, if we continue business as usual, we'll have more plastic waste than fish in the oceans, and we have to define the ocean water. A major component of ocean water is plastic waste. So this is a really the motivation that we started to work on this problem, because I didn't mention in my mini bio, my father was a chemist, and I was I was recalling that when I was growing up, he was very proud that he was making polymers in the 1940s in Japan. And he was very proud that he could make the most advanced material in the lab at the time.
Yeah.
He passed away in 2006. One day I was thinking about this. I said, oh my God, the polymers that he made as an undergraduate student, those polymers are still on Earth in different kind of form and shapes. And that's really a stunning revelation to me, because he lived a long life of 86 years old. I can write a whole book about him someday. But the polymers he made outlasted him. So I was very concerned about this whole situation. And I thought, gee, the chemists and chemical engineers probably helped created the problem, so probably we can find some solutions to help reduce the waste. Because if we continue the business as usual, the consequence will be unimaginable, because the rate of production of polymers, the plastics, and the wastes, the amount of these are growing exponentially. I don't know whether you have seen those curves.
No, I haven't. I'd love for you to share any slides that you may have.
I can send you a slide about this exponential growth, because in the 40s, I said in the 40s, it was a brand new material. There was they were just the most advanced material in the 40s. But over the last 60-some years, we have grown this exponentially, the amount of production. And right now, I don't know whether you saw the news release, we have about 6 billion tons of waste in the landfills.
Oh my God.
And 125 million tons in the oceans. 5-6 billion tons, that means one person on average owns about 1 ton of this plastic waste. The problem is not they're not accumulated in a neat place, in a secure place. These are in landfills, which are not perfect, and they're in oceans. And this is basically not you cannot retrieve these things completely.
Yeah.
So if we continue like this, the consequences are unimaginable. And unfortunately, most people think they put the plastics in the recycle bin is the end of business. That's not it.
Yeah.
9% was actually reused, and the rest are, as I said, stored somewhere in landfills or scattered over the continents or in the oceans.
So
And
I would say there's like two sides of the coin. One would be for consumers to obviously reduce their plastic consumption
yes,
as much as
reduce,
possible,
replace. You
and or
use it.
reuse, or not throw away, which is like the culture that we because we have designed all our production systems without the end part, which is like the death of the
It's linear,
product.
right?
We have this linear system,
Right,
then consumers are used to just throwing stuff away. And
right.
then you're on the other end of the spectrum, which is you can bring some science onto the equation and say, well, how do we transform all this that's left over?
Right. The problem, the
But
problem
the
is
problem is
that,
recovering, or go ahead.
well, the problem is we only collect about 14% of the waste. Okay, out of the 14% we collect, only 9% is really recycled. And the reason is the following. When you collect this thing as a mixture of the 7 types, there's the only limited options to convert this complex mixture into any useful or valuable products. So how many park benches you can make, right? Or how
Yes.
many, reusable bags you can make. So these complex mixtures are difficult to convert them into useful or valuable products. So most of the people think we just simply burn them, okay, convert them into CO2, but then you have to worry about pollutants into the air, and eventually
Yeah.
it will come down to the water.
Is
Or the problem is the energy recovery from this is very little, so you have to pay somebody, pay a tipping fee for somebody to do it. Otherwise, they will lose their shirts in doing the incineration.
is there a clean way to burn plastic?
Yes, there are some advanced technologies to clean them, to do the clean burning. The problem is that it's not a cost effective.
I see,
You
I see.
don't the business cannot make a lot of money. They have to be paid to do it.
Well, I
Uh,
think we're at a point where it's, this sounds a little bit utopian, but we need to change our goals, right? The goal is to
yes,
survive and to protect life as a whole. The goal
yes.
can no longer be to maximize shareholder value because
No,
there's going to
no.
be no life to enjoy that shareholder value.
Right, exactly. I
Right.
was asked about the energy balance, material balance, and how this thing, is affect the overall, crude oil consumption, etc. I said, yeah, those are important, but the most important thing is that we're facing a very serious threat from this plastic waste. So yes, I mean the right now the business cannot. They can only do so much. Convert this complex mixture collected into some useful products. And there are some companies trying to convert this into fuels, and by using pyrolysis, and that could be a good solution.
By using what, sorry?
Pyrolysis, another burning
I see.
without oxygen, so they can convert them into oil. But their oils are lower quality fuels, so they have to go through further treatment to convert into actual fuels to be used in the vehicles. And we're using a different technology. We use supercritical water, which is the safest solvent to convert them into a high quality fuels.
All
And
right.
not only
What is,
that,
sorry, go
yeah,
ahead.
yeah. So not only that, we can tune the conditions to produce some other products besides fuels.
So, what is supercritical water?
Supercritical water. Okay. It's a highly technical term. So at certain high temperature, high pressure, the water will expand into the become a supercritical water, and which has very low density, but it has a wonderful solvent properties. So this can dissolve the melted plastic
Wow.
and do the conversion, to chop them into smaller fragments, and we can convert them all the way from polymers to monomers, in other words, single units. But I think the intermediate ones probably are more higher valued and more useful. In other words, we can convert them into a clean crude oil, light crude oil mixture, and that can be made into many different chemicals, and we can convert them into fuels that you can use in the diesel truck or in the cars. So,
Wow.
yes. So I hope this message also motivates people that, if you can help to collect this sorted, clean waste plastic, then we can convert them into useful products. So instead of throwing into the trash bins, you should encourage your local waste collection facilities to collect individual types of the different plastics. Then we can find the most cost-effective solution for each type that's more higher valued. So hopefully the recycling industry will be motivated to do it if they have profit, because nobody's going to do anything if they don't have profits, right? I mean, business.
Yeah, of course.
Yeah. So because in addition to that, I think as a whole, we should have some goals, like in Europe, to have zero plastic waste input into landfills by 2030 or 20 some years. We should reduce that. And in Europe, they have such a goal, but not in the U.S. and or some other countries.
Yeah.
So I think these are very urgent, urgent problems. We cannot just do nothing because, we probably have 20, 30 years to fix this problem, because by 2050, you have more plastic waste than fish in the oceans. That will be too late. Don't you think so?
Well, yeah, and the oceans produce about 2/3 of the oxygen that we breathe, right? So
Right.
no ocean life, no healthy ocean life. There's no healthy food, no healthy air quality for us.
Right. I mean, it's very, very serious threat. Yes.
So you at your research lab at the university, you with your team, you came up with this method of transforming plastic. What's the story behind this? How did you get there?
How did we get there? Actually, we as I mentioned in 2011, 2015, we developed the solvent extraction methods, which were very effective for polymers like polycarbonate. But some of the polyolefins, they're very stubborn. They need high temperature to dissolve, and sometimes we run into difficulties to restore them into a pristine state of polymer. In other words, to clean out everything and to be virgin-like polymers and then reuse them.
And this was starting with electronic waste, or
Yes, we in 2011 we look into the computer housing, which is a polycarbonate-based polymer. It's a polymer blend, and there was a major company that had 4 global teams trying to solve this problem for a decade, and then they finally came to us, and so we found a solution for the polycarbonate. But then I realized, oh my goodness, this is only 1% of the total plastic waste. So that's how the
wow.
the
Okay.
interest started. I thought this is a very serious problem. We have to solve it. But I have not had very much luck in getting funding from the companies, because the companies said they're working on them themselves, and big companies, and small companies said, well, this is a government problem, right?
Oh.
And I went to the National Science Foundation. They say, oh, this is not a fundamental problem.
Yeah, right.
And and what is the cost? What's the energy balance? What is the life cycle analysis? I said I didn't have any funding. How could I do all that? But even if I have done all that, they will say, oh yeah, you have solved the problem from the fundamental point of view, then go to the industry. The industry should solve this problem. So I'm getting nowhere getting research funding. It's really has been a very discouraging process.
Well, maybe you should talk to the guys at TerraCycle or Loop. You've heard about them?
I heard about them. Where are they?
So they're in New Jersey, and TerraCycle. So I'm gonna for everyone listening, this is gonna be a 2-episode series. One interview is with you, Linda, and the other is with Tony at Loop and TerraCycle.
Oh, okay.
And you guys are tackling the same issue in different ways, let's say.
Right, sure.
So TerraCycle they made big sort of like agreements with big companies to recycle and reuse plastic. So for, let's say, shampoo bottles that are made with plastic ocean or stuff like that.
Yes.
And then they created Loop, which is launching in May in Paris and in New York first. And Loop is a company that will pick up from your house the containers that are no longer made of plastic. So let's say you bought some ice cream. It no longer comes in a plastic pint, but in a stainless steel container that will then be, what's it called? Sterilized and reused and sent to another customer. And so that way there's a loop and there's a collaborative sort of exchange of, and we all share containers and all that stuff.
Right.
The problem still is that, well, there's a very little percentage of the plastic that's been recovered from landfills and the ocean. And second, there will be a moment where, I mean, there are definitely steps in the right direction, but you can only recycle plastic so much.
There's so many times,
still so many times, and then what do you do after that? Which is where you come in. So I think,
thank you for making that connection. I will try to reach out to them. I have been very
a little early, but I think there might be an interesting synergy there, or
sure,
since they're in business and it's working. So
right. Sure. Yes, I understand.
So that process that you and your team have come up with, the research is there and it's a pretty cost-effective way to treat plastic, we transform plastic because it's just with water, or does it require very expensive equipment?
The equipment cost is can be reduced, I would say. So that takes further research to do that. I'm talking with many experienced engineers, try to make this equipment reduce equipment costs, and water is probably the best solvent or processing fluid that you can use. So there will be further research needed to make an inexpensive process. I have talked to several very experienced engineers, and they are very optimistic that this can be very cost effective. They can reduce the cost of the equipment and make it widely available to reprocess the end-of-life plastics.
So once, let's say this this actually gets picked up and we start doing that, it's still creating fuels for the old model of transportation that burns. It's still burning fossil fuel, but we're sort of getting rid of plastic.
Yes, I think it's absolutely critical to reduce this plastic waste accumulating in the environment.
Yeah.
So we can convert them into feedstocks for many other chemicals, which can be used for other uses like solvents or other chemicals that can be, this can be used as feedstock for many other chemicals, not necessarily fuels. If we go to electric cars, we don't need fuels anymore. Still, we may need other chemicals, pharmaceuticals, and so on and so forth.
Yeah.
Yes.
Excellent.
Yes. Yeah. Fuels is at least is a one of the solutions. I'm not claiming that is
There's
the
many
entire
different
solution.
potential uses, you mean?
The oils that we produce and the chemicals we produce, if we break down into monomers, that can also be resynthesized into different chemicals, right? So we're not increasing the amount of fuels. We're just replacing the fuels produced from the crude oils right now. So you don't have to go to the deep sea to recover crude oil, very hard way. We can can just,
In terms of natural cycles and energy cycling on the planet, we've taken all these reservoirs of carbon and all this and taken it out of, we just consume so much of that and created this massive problem with the amount of plastic, the outrageous amount of plastic on the planet.
Right.
Well, it's very exciting. You wanted to share some slides as well. Will you, if for people listening, we can put them on the show notes on mastersofregeneration.com/podcast on your episode.
Okay.
And if you want to send them to me.
Okay, let me think about it. Yes, I can select. How many slides do you want?
As many as you want. I mean, it could be 5 slides or 10 slides, whatever illustrates and whatever people can see visually a reference to what the, let's say, the challenge is and the proposed solutions that you and your team have come up with. I think it's a very interesting point because to me it's sort of like the other side of the coin. So what happens if we think of our relationship to the natural world circularly? Then you come in and you're like, okay, well, we can transform this, and then it doesn't keep adding to landfills or the ocean, and we can reuse.
Yes, we're even if we convert all the polyolefin waste into fuels, that's only a few percent of the fuel consumption. That can only supply a small percent of the fuels that we're currently using. So it's not it's not going to threaten any petrochemical companies producing fuels. We're just trying to find some use to reduce the waste.
Of course.
We're not in any way threatening their business. But as I said, our motivation is probably less from the profit or the material balance point of view. This is probably still a temporary solution in the long haul. But at least as we reduce the waste, we reduce the risk to the environment. I think that's our important goal. But of course, technology alone is not going to solve this complex problem. That's why I'm coming to you guys and reporters and to talk about this because I think the public should be aware of the problem, help to solve this problem.
I think probably the biggest issue of our time, I think, in terms of consumer related issues, is the lack of knowledge, and so that means there's a place for a lot of education to happen.
Right.
right?
Yeah, because I hope this will motivate the public to help. Because even even if we have the best technologies, still, if the wastes are not collected, you know, there's no solution to that, right?
Yeah.
Right now, we are only collecting 14%, so that number has to go up. Otherwise, if we have business as usual, as I said, the consequences are not imaginable.
Yeah. Linda,
Okay.
is there
Yes.
anything else that you'd like to add that we haven't covered?
I think we have covered most of the the problems, right? So yes, I think the yeah, I think I like the public to know that we appreciate your help to inform all your friends about the threat of the plastic pollution, right? Which is probably, in my opinion, is more dangerous than climate change. And secondly, if everybody reduces the single-use plastics or replace them with other materials, we may have to go back to glass, aluminum, or other natural plant-based products.
Yeah.
And please do not throw the used plastic into trash, because once the waste is into trash, the cost of retrieving this plastic waste from the landfills is about the same as the cost of producing virgin plastics from crude petroleum. That means there's no business can compete with the chemical companies to produce, to do that. There will be no profit
Wow.
for
Yeah.
this activity.
There's so
And
many countries that don't have any recycling whatsoever. I lived in
right,
Tokyo and there was very sophisticated recycling, but in Colombia or Brazil or
right,
Ecuador and many other places, in
right.
Paris even, the recycling is not well organized, you know?
No, no. So if they can become aware that once you throw the plastic waste into trash, that's also very costly to retrieve.
That was a great insight. Yeah. Thank you
Yeah,
so much
and
for that.
if you can clean the used plastics, and if the collection system can collect them in sorted way, then we can find cost-effective solutions for each type of the plastic waste. And this will be very helpful to reduce the plastic waste accumulation. But that probably will need the waste management system. They have to be more sophisticated in collecting this sorted clean plastic waste. And I think the plastic makers, the producers of plastic products should be also be aware of the cost of recycling their products at the end of life. They should design the products to be more easy to be converted into useful products. If they have 9 layers with complex components, aluminum, this and that, that will make the recycling not profitable. And I think they also have to cooperate to make this happen. So I think without the goals or policies to legislate, the zero waste, plastic waste into the landfills, if the whole activities are driven by profit, then the business, has to make a profit by doing this. So all these things have to be, changed, to make this happen.
Yeah.
So I hope that at least this discussion will bring some attention to this problem, and maybe this will motivate the change. That's my hope.
Yes, I'm with you. I hope so too.
Well, Linda, thank you very
Yes.
much. Where can people go to your website or the university? Is there a website that people can go to and read more about this, about your work?
Yes, yes. There, I think you have the news release, right? That news release was widely read.
Yeah.
So we are in the process to have a website
Okay.
set up, and I'm discussing with a computer expert next week about to have a hub of this. Maybe we can connect with the industry, with the public through the website. But this is still in progress. So we hope this will initiate a change or make an impact on this problem.
Excellent. Well,
Okay.
I'll put on all the links that I have on the show notes, and I look forward to seeing where it goes and where your work,
Yes.
how your work
Yes,
unfolds.
yes. There is an engineering website. The College of Engineering website has a little bit short YouTube video. Did you see that or not yet?
I haven't.
Oh,
I'll check it
okay.
out. Yes.
Yes. It was in the news release. It's
Okay.
in the College of Engineering website. It was cited in the news release. Okay, so you can click that, and there are some elementary school teachers already asked for permission to show the video for the elementary school students
Yes.
to bring awareness to this problem. Yes. Thank you.
All right, Linda. Well, thank you
Okay.
very much.
Yes, thank you for giving us this opportunity. We'll be in touch.
Yes, please.
Yes.
Take care.
Okay.
Bye-bye.
Thank you. Bye-bye.